Hello and welcome to section 2.2a, polynomial functions of a higher degree. And so we're going to take this higher than a quadratic function. So basically the general form of a polynomial function is f of x a sub n. Now that's just counting that we're dealing with some n, x to the n, plus a sub n minus 1 x to the n minus 1. So we're saying that we have a power, and then this could continue all the way down to a sub 0 x to the 0 power. And so that would end up giving me a polynomial function. Now what we're used to seeing is a polynomial function is this. F of x might equal like 3x to the 8th plus 5x to the 7th plus 6x squared minus 4, something like that. And so then this is x to the 7th, this is x to the 2nd, and so you can have all the x's all the way down to, or you could be skipping some. But a polynomial function is basically a function where the degrees, the powers themselves, are all positive whole numbers. And so that's the key, is that for it to be a polynomial, you need to have positive whole numbers. And so then, when we talk about the degree of the polynomial, the degree is the highest power. The degree of the polynomial is the highest power. And let me go back to the general form. The general form always starts with the highest power and kind of works its way down. And so if you get it in that form, but usually if they're asking you what's the degree, they don't always put it in order from the highest power on down. So you have to look for the highest power. And so the degree of the polynomial that I did up here would be 8. And that's really all I'm looking for, because that's the highest power on this. And then what is the polynomial's leading coefficient? Well, that is the number in front of the x value when we are on the highest degree, on the degree. So in this case, my example up there is 3. So how does this have any effect on us? Well, if our power is n, so if we're talking like x cubed or x to the even x to the first, but x to the 5th, x to the 7th, and either they're added or not, you're going to get something that looks like this. So like this first one here is x cubed. If the leading coefficient is positive, meaning greater than 0, so like say 2, you're going to get something that looks like this. So as x approaches negative infinity, that's what you're seeing down here. As x approaches negative infinity, as we're going this way, our y values go to negative infinity. If we're going x to positive infinity out that way, you can see our y values go to positive infinity. That's standard if n is an odd number. And if we have a negative as a leading coefficient, that would be for these guys. If we have like, this is x to the 1, 2, 3, 4. This is x to the 5th power over here because we have 4 terms in it. And so this would be have a negative in front of it, because as x goes to negative infinity, we go to positive. And so it reverses. If the leading coefficient is positive, of an odd value, it'll always go like this. If it is negative, it'll go the other way because it's flipping it over. Remember, reflecting it over the x-axis. So think about what we've learned before with other functions compared to what we're doing here. So then if it's even, like x squared, x to the 4th, x to the 6th, and so on, like this guy is x squared and this one's x to the 4th of some function. When it's x to the 4th, or an even power, you'll notice that as we go out to positive or negative infinity, we go to the same y values, either positive or negative infinity. So as x goes to positive infinity, we go to positive infinity if the leading coefficient, if a is greater than 0. So this one was a was less than 0. This was, or sorry, I said that wrong. Let's re-erase that. That was a was greater than 0. The leading coefficient was greater than 0. This was the leading coefficient was less than 0. Over here, the leading coefficient would be greater than 0 because they both go up. And if the leading coefficient is less than 0, they both go down for an even function. So that's what I was talking about up here, that I had a negative. My leading coefficient was -1, so less than 0. We start up in the negatives and go down. And so then a way to kind of write it with limits is what I was talking about. From the left-hand side, from the negatives, as x goes to negative infinity, as we work our way out to the negative numbers, we're going to fall. And likewise, this would be This would be an example of a negative x squared function or something like that, or an even power, because they're both going to the same y values, but we're going different direction. we're going to different infinities in our x's. So we'll talk more about this when it comes to class time. So then a polynomial function will have at most n real zeros. So when you're looking at your function, if I have something like x to the third power, so that would mean that I could have, it doesn't mean that I'm going to, it means that I could have 3 places where it crosses the x-axis. That's what we're talking about when we're talking about zeros. So it could be 3. It doesn't have to be. At most 3. Let's say at most. At most, for this value, whatever the highest degree is. Then, to find the number of maximum minimums, like for a cubic function you might get something that looks like this, you can see that if this was x cubed minus x or something like that, you're going to get turns where it's going to turn back on itself, and those where the maximum minimums appear. It is always 1 less, n minus 1 less than the actual power. So you can see that there's 1 maximum, 1 minimum in this one, so there's two relative max and mins in this function, so that's 1 less than the degree that I was talking about. So then some other terminology that we're dealing with and things that people get confused on, so please pay close attention to this. We're talking about zeros of a function. There are many ways to write these, but the zeros of a function are basically the places we cross the x-axis. So they're called zeros, solutions, or roots of a function. So we're saying when x equals some number, that's where our function is crossing the x-axis, and so c is our solution to the function, or a root, or a zero. And so you just got to get used to the different terminology that we may ask you one time for a zero, the next time for a root, the third time for a solution, and we're going to rotate, and so you just got to get used to those 3 terms. If we get to a place where we have like x minus c, and c is some number, then that's what we call a factor. If we set that factor equal to 0, it will solve for a 0, a root, or a solution or something like that. It'll give us those if we set x minus c equal to 0. And then if it's written as c comma 0, then this is what we call, this is our intercept form, our x-intercept form, and the c is the 0, the solution, or the root of the equation. So all of these guys go together, but they're just different forms of the same thing. So if you have questions on these, please come to class prepared to ask them.